welcome to Desk Ladyada.
Hey everybody, and welcome to a Desk of Ladyada. It's Sunday night. We're here at my desk doing a little bit of engineering and coding, as well as some purchasing, and also just hanging out, enjoying this beautiful last weekends of the summer before September kicks in. Never want to pass up a nice night in New York. We went on this Ferris wheel. Maybe Phil will post up.
Yeah, I'll post up some. There was like NeoPixel like thing on it, so that'll count. Because someone will like, why is no electronics in this? So
there's electronics in the Ferris wheel.
So I think I can get away with posting.
Okay, cool.
Posting that.
All right, well let's check out what we're hacking. Do you want to do? Let's do this LED thing first, and then we can show off.
What do you want to do?
Okay, so let's go to the overhead. So we have this design. This is the LED matrix driver that we put in the shop. It's lovely. It has 13 by 9 RGB LEDs. It'll break out, ready for use. And then we made the LED glasses, which is basically the same design, but just sort of exploded out. So it's like you could kind of even see it's like this component is here, and then all the LEDs are spread out over the glasses. And so one of the things that we did, we're going to kind of put it off for a week, but this weekend we sat down and actually started doing the mapping of the LEDs. And, even with this, the LEDs don't map perfectly into memory. The memory isn't like, LED 1 is spot 0 and it's totally even. There's actually a little bit of a memory map thing going on with that. And we had already programmed in this memory map before, but now we were like, okay, time to do the LED glasses. And the LED glasses are kind of weird because this is a straight up grid of 13 by 9 RGB LEDs. But this has two round elements and then like a grid element. So you can kind of see there's like a 5 by 12 grid of RGB LEDs. So you can have like kind of text or like isometric, like XY mapped graphics onto it. And then on the outside, there are two 24 LED rings. People like our NeoPixel rings, so we thought let's take that same kind of fun LED glasses, that round shape that people dig, and then make it a little bit different than just a plain, glasses that have XY. You can buy those; they're available. We want to do something a little bit different. We also put together the LED glasses driver prototype, which looks like this. So this is an NRF52 840, the microphone, accelerometer. This is an on-off switch. This is a slide switch that you can use. You can turn it on, turn it off. There's one kind of action button. Okay, I figure you don't really need more than one. And then a reset button to reset the board or put into bootloader mode. USB-C and battery. And there's a battery charger, so you can use this with LiPo, but we're actually going to make it by default not work with a LiPo. It's going to be for alkaline batteries because you can't have a charger for both. You kind of have to choose one or the other. But I think by default it should be alkaline batteries because I think those are, especially for something on your face, a lot of people aren't going to be comfortable with like having a battery taped to their skull, and if it gets hit, it can get punctured. Why risk it? So there's a little jumper that you can solder closed if you want to use a LiPo battery. So people who are advanced enough to use a LiPo, they're also advanced enough to be able to solder closed that jumper connection. I think that's fine. Yeah. And then I'm just using a Stemma QT connector because one of the nice things is this is an I2C chip. So, I can just use our, ready to go shorty I2C cable to make this into, glasses where this is the leg of the glasses and then this plugs into the front side of the glasses. And then I think I already have a program on here that'll let me turn it on. Okay, and then maybe this will light up. Maybe not. Hold on. Maybe I was programming it with it. So let me plug into USB.
All right. Live demo.
I know, live demo.
Live demo.
I don't know what was on here because I was messing with it earlier. Okay. Oh, I was writing some code, so hold on a second. LED map. I moved the LED map into a global, so I just have to make it reference itself. Okay, great, there you go. So this is the mapping of the two rings. And so, they look like they're, when it's mapped, it's like, oh, like 0 through 1 through 23, and they'll go in order. But these LEDs are absolutely no way in memory ordered this way, right? And this is a thing that, like, kind of, I was chatting with some of the engineers, and I was always kind of shocked at, like, how, we have 30, 40, 50 years of combined programming experience, and yet we're still kind of programming the same thing. Like, programming has changed, but it kind of hasn't. So doing memory remaps or debugging with printf or like programming in a simple finite state machine, it's kind of like the tools are getting better, but the programming itself has not changed. Like, we really do have the same core issues and the same core ways of programming them, which I think is kind of cool. It means that, like, if you learn programming from one language, you can take that knowledge and move it to another. So if I look, if I open up my code, and I actually have a little bit of demo code here.
Do you want me to go to the computer?
No, so this is, if I show here, this is a program that lights every memory spot in order. And you can see that there's some of them go kind of in order-ish, but then it kind of like flickers around and it sort of goes a little bit over here. It's not totally random. There's like micro patterns, but for the most part, you can't easily guess where the next LED is going to be, because you see it does flicker around. So this is me saying each LED 1 through 351 are G and B LEDs, each individual one. So that's why you see it's red and then green and then blue, and then it flickers through the whole body. So then you have to figure out, like, well, how am I going to take this map and transform it into what is a useful map where I want to address all the LEDs, or I want to address the XY of the matrix. And this is kind of something that I'm doing, like, every month I have to do this for something, whether it's like an OLED or a TFT or an LED driver, or like, there's always some, like, memory is X and out, the final result is Y. Key matrix mapping, all that stuff. So how do you do this? Is there some magical way of doing it? And the answer is no. You just sort of do it. And the way I did this is I actually ended up just writing a simple program where I would I'd light up each LED one at a time. So this is LED 0. This is address 0. The first LED in the memory map for this LED matrix driver is this LED. And so I would actually kind of write down in a gigantic piece of text file, okay, LED ring 1 blue is 0. And then I would, increment this number to 1 and save it. And of course it crashes because that's my luck. Hold on. I'm doing a lot here. Okay, so this is 0, blue, and then I incremented my code to 1 and I save it, and it goes green. Okay, so now I know LED, the right ring, LED 1, address 1 is the green LED. And then, of course, when I go to 2, that isn't red. You think like, oh, it'd be blue, green, and then red. No, actually, because, again, this memory map and this layout is kind of all over the place. Address 2 is actually on the other side in the ring. It's like the 17th LED, blue. And then 3 is green, and then address 4 is red. So that one is in order. So I just sat here for like an hour and a half while Phil was doing other fun stuff. And I just mapped every single LED to the LED ring where it was. And sometimes, there's always just like, oh, can I do it algorithmically, or should I do it with like a literal like map? And I always recommend starting with a map, even though sometimes, to save code space, eventually you want to go to an algorithmic method. But I actually recommend making a map and then simplifying that map, like optimizing that map, before you try to like figuring out like you could look at a schematic and try to figure out what is it like this, perfect algorithm that will map every LED to every location functionally. Sometimes you can do it, but often you kind of can't. And I just recommend doing it with a text map. So I'll show you the text map code. So if you go to the computer. So this is the code, I just sat down and I did it. So this is the LED map for each ring. So, LED 0 is 341, 211, 210, that's red, green, blue. And then there are patterns, right? But I kind of do the pattern stuff later. And this is the right ring. And so you can see for LED 0 on the ring, the topmost, it's 287, 31, and 30. Those are the 3 address maps that map to the LED. And what's really nice, and I recommend this if you're ever having to do this, is even if it's more work, try to get this work to be done into an interpreted language rather than compiled, because one of the nice things about this is every time I wanted to test each LED location, every map, to figure out where it ended up in the output, I could just increment a number and save it, and it would immediately run. Whereas with Arduino, I've had to do this before, and it takes a really long time if you're doing it this way, because you have to upload every time you increment the number. And so instead, what you can do is try to have a space bar that when you press the space bar on the serial console, it'll increment, and you can do it that way. So I happen to like the interpreted way, but you can do it with compiled. You'll just have to do a little bit of, maybe a button to have it increment, and then it prints out what it's doing. But yeah, go through and then map every LED, and then the upshot is when you're done, you can have code that looks like this, where I can add I can index into the ring object from 0 to 23 and set it to be a color wheel, and that makes the rainbow glow here. So that's.
I'm gonna show that.
That's memory. No, I'm gonna show here. Honey. So that's cool. So this is just the 2 rings, and then the next step is going to be to do the XY matrix underneath, and so you'll have 3 objects when you want to address into this PCB. You'll have the left ring as a NeoPixel ring, the right ring as a NeoPixel ring, and then an XY for the grid of LEDs that's overlaid onto it. So that's that. So more to go, but much math has been done. But there's no real shortcut. People always say oh, what's the secret? And the secret is you just sit there and you just do it. And then after you've made that map, then you can look and see if there's any patterns that you can use to simplify it. Sometimes there is, sometimes there isn't, but nothing really beats just sitting down and doing each LED in order until you make the map up. All right, any questions about that before I move on to the
No, keep going.
next thing? Okay. All right, next up we got a teardown. We picked up a paper shoot camera. So let's bring this up here.
Yeah, so just to be straight up, we're thinking about doing some type of easy DIY CircuitPython powered digital camera.
Maybe with machine learning and stuff, because there's the machine learning, for cameras.
We wanted to see what was out there as far as anything with the circuit board, anything that was sort of in this category. Not really anything. So,
but we did find this.
We did find this, so we bought it.
It was kind of cool. So they're not inexpensive. I'll say that this costs more than a nice camera, but they did do a pretty good job with it. It's got kind of that retro charm. So the camera comes as a PC. We already put the batteries in because we wanted to make sure.
And an SD card. It looks like you can use a mini card, but
there's a micro.
I didn't try that out yet.
There's a micro SD card on the back. It looks like a micro SD slot. SD.
You might want to make sure you keep staying in focus when you do this.
Yeah.
Going up and down.
Well, I'm doing the best I can.
Yeah.
So it runs off of 2 batteries. So there's going to be obviously a boost converter, and you can see even some boost converter technology on the back here. I'm going to zoom in so I can get to the components. So I think here, it looks like there's an inductor, there's a little boost converter, that's a micro SD card. There's a buzzer, there's a little speaker and a speaker driver over here. It does make little noises when you take a photo, which you kind of need to because there's no TFT.
It makes a clicking sound when you take a photo. But the other cool thing is if you take the SD card out and you try to take a photo, it'll, go for it.
So that's the photo.
So you take the photo, and then take the SD card out.
If I take the SD card out.
Yeah, and then do it. Nope.
Yeah, it makes a little sad sound. There's also a microphone because it can take little videos.
Yeah.
And
didn't figure out how to do that yet.
in here, this is just a little. I don't want to take this apart yet, but there's a little camera. This is a camera module with like a built-in lens, and then it has a little piece that goes on top of it that helps you focus the lens. Because even the little micro modules, little camera micro modules, you can zoom in and out with them. I don't know if anyone really messes with this. I'm sure it's just tuned for infinite distance. There are some cool stuff here. Hall effect looks like Hall effect sensor, UART, I2C. Of course, that would require you to be able to program it, which I don't think there's really access into that. Micro USB, you can use that to read files off of, and if there's a DFU, I'm sure there's a DFU system. And then on the back, some more. So yeah, there's actually not that much circuitry, to be honest. Right, there's this little flash memory. This is probably the program memory, not the camera, not the storage memory. A couple other power supply things here, probably needed for this chip here. This probably gets boosted. This is 2 volts or so, gets boosted up to 3.3 or 5 volts, and then converted down to probably 1.8 and 2.8.
And apparently, maybe you can point this out, the batteries can be rechargeable batteries, and you can recharge them via USB. So
I'm not actually sure about that.
I know. It says on the box. A couple things it says on the box.
I'm not sure about that because
I'm
a little suspicious. I wouldn't recommend it. I would use alkalines. And then looks like here FL. I think this is probably flash. There's probably an add-on or an alternative version. I will say that this board has gone through a couple of revisions at least, because the photo I saw online when I was kind of looking at this did not have an all-in-one chip. It had a chip plus a SRAM chunk. And this is like an all-in-one chip. This chip is a Novatech NT96658. It's an all-in-one camera chip. These exist. There's probably no data sheet for it. This is a Taiwanese company, and also probably a Taiwanese chip design. They probably worked with the company and said, look, we just want this chip that there's no TFT. Again, there's a little viewfinder that you would look through to take a photo. And then, did you want to show some of the photos? You said you wanted to share.
Well, I can just show. I took one in just color mode. I didn't even point it right or figure out anything. And then I took one, and it's black and white mode, which I thought was pretty good.
Take a photo.
Yeah. So let me just grab them real fast. Thought I had them ready, but I did not.
That's okay. Well, you mentioned them earlier, so I thought.
Yeah.
So this is a color photo. So it's kind of got the, a Lomo lens type thing going on there. And then this is a black and white one. So there's 4 filters. Let's go to the overhead again. I'll show the filter thing. So when you get the camera, zoom back out. The PCB comes bare, and then you have there's a variety of different paper enclosures. Now, I will say that they're like, oh, this is an eco-friendly camera. That's not really true. I mean, like, you have the same ecological footprint as any other camera, just because
I've learned there's no nuance. So
there's no nuance, but I'll say just this is it's a cool camera. I wouldn't don't buy this if this is the most important thing for you to save the planet. Just don't buy a camera. So you put this together, and then there's bolts, which I'm not going to put on, but you bolt this together. So you kind of have it in pieces, and it kind of has this nice like paper look. And then what is cool here is this is like a little magnetic ring. Here it's probably like actually what makes it kind of expensive is you can then attach lenses, like a fisheye lens or whatever, using a magnetic ring, sort of like on a smartphone. And this is the button that you press to take a photo, and then again this is that viewfinder. No TFT, and then there's only one UI element, and there's this switch. And if you look carefully at the switch, this is a 4 output switch. There's color, black and white, green and purple. Actually, I don't know what the green and purple is. I'm assuming sepia tone.
I gotta try that.
Yeah. Really tried the color and the black and white, obviously. But there's 4 options. There's 4 filters built in. That said, it does do video. The image quality is quite good. It is definitely an all-in-one camera thing, and you can't hack it. So if you want something different, you can't. This is all you get. But I thought it was kind of a cool story. It's this Taiwanese engineer who designed these cameras, and just wanted it's kind of a little bit of like an NYU ITP type project, but became a real product. And now these are super fun. Also comes with a lanyard you can wear, so kind of cool.
All right, and then we were looking at this 4-position switch.
Well, is there any other questions before we?
No, keep going.
Okay, great. Okay, cool. Yes. So I thought for the great search we would show how to
Why don't you show that switch?
show the switch on the back, which is
Show the switch, and then I'm going to go into great search mode.
Yes,
Okay.
a 4-position switch.
Where in the world is that part I need? The great search with DigiKey.
The Ask of Ladyada brought to you by DigiKey. Thank you, DigiKey. And Ladyada, you use your engineering powers every single week to find things on DigiKey. What is the great search this week?
Okay, this week we got this paper shoot camera that we just did a little bit of a teardown on, and I really like this 4-position switch. I'm a huge fan of slide switches. I really think they're super awesome. I mean, I like buttons. Tactile buttons are good, but if you're not doing tactile buttons, I really like slide switches. They're easy to understand. They're you can use them even if you aren't looking at something by feel, which I really like. So they're good for accessibility. They last a long time, for the most part, unless they get wet. But you can still get weatherproof ones. They're good for power. They're good for signal. They're good for everything. So on the LED glasses design here, I've got. This is a slide switch that I use for on-off, so you can turn the whole thing on and off pretty easily with the slide switch. There's also buttons, of course, to do reset, but slide switches are where it's at, in my opinion. And I've used, single pole, single throw switches, which are kind of rare. I usually use tactile buttons. Single pole double throw, which is an on-off. Single pole triple throw for 3 modes. But then this was a fabulous single pole 4 throw, and I thought let's check that out because this could be useful for other people. And I like that it's a through-hole switch. You could easily add it to a design to add 4 elements of selection. So let's go to the computer, and I actually wanted to show real fast. Different switch schematics and what they mean. So this is, I always get confused. What's the pull and what's the throw? So if you don't remember which is which, don't worry. I've been doing this for 20 years. I still can't remember. But the most common thing is, a single pull, single throw, which is usually a tactile button. It's just you press it to turn it on. There's a single pole double throw, SPDT, which means there's a single thing and it can throw between 2 options. So that's usually an on-off switch. There is the single pole triple throw. So again, 3 options. And then I'll note something that it always, doesn't trick me up, but can trick other people up. I'll go to this image and make it nice and large. So the single pole, single throw is SPST and then SPDT. And then you'll also often see DPDT. That's the dual pole, dual throw. I see these often because surface mount slide switches for mechanical strength, they often have 2 separate switches. It's also good, the double pole, double throw, if you want to. I like these switches when it's I want to switch I2C or UART connections. You want to switch a simple 2-wire bus from one set of pins to another, or from controller to peripheral. I like the SPDT or DPDT. I use those often on our shields, like for GPS modules, where it's do you want to use UART on the soft serial or the hardware serial? One switch switches both pins over between 2 sets. But then when you get to SP3T and above, you don't use T, use S for single. D for dual, but when you get to 3 or 4, you use the number. So just remember that. Don't SPTT does not exist. There's no T for 3. You actually use the number 3. So, it's good to know when you want to search for it, because when you go to DigiKey, you can search for SPST, and you'll get all sorts of like toggle switches and stuff. Then SPDT also. Totally awesome. Lots of different options. Relays also, you can get them in SPDT type. But if you want to do, 4th row, it's not SPFT, which sounds like something you put on your skin to avoid getting burnt. You actually want to do SP4T. So SP4T actually will get you, the thing you want. And I think you can get 5T, but 4T is kind of maxed out. DT and 3T are kind of not too uncommon, but 4T is quite rare. In fact, it's so rare that there's only 31 options in slide switches. There's also RF switches. There's the soft switches. So that philosophy of like, there's a throw and a pull. The throw and the pull might be completely software implemented, which is what you'll get with RF switches and stuff. But for slide switches, toggle switches also, those are, you can use those, but they tend to stick out a bit. Not as easy to implement in a design. For slide switches, there's not that many, they do look kind of like what we want, but there's not a ton. That said, let's only look at the ones that are in stock and active, which cuts it down to only 8 options. Really not that many. But all these look pretty good. This one I thought was like really compact, surprisingly so. This looks very slim. So I don't really want this one. And this one is a right angle. One thing to note when you're programming these, when you're putting these into your design, really look at the datasheet very carefully, because it's not like there's sometimes 2 pins, even though it's a single pole. Sometimes there's 2 pins for the mechanical layout. Sometimes there's 2 poles, and sometimes they're not in the order that you think it is. Like the leftmost switch is not the leftmost pin or whatever. So just really read the data sheet and maybe use a multimeter when you get the part to really make sure you're mapping it correctly. But these all look pretty good. There's like a bunch of right angle ones. There are voltage ratings. If you're using these for power switches, check out the voltage rating and the current ratings. You can get switches that are high current, high voltage, but what I like to do is if I really like a switch, you have to switch power, I'll connect it through to a transistor, and then the transistor does the switching itself. But that said, the one that I kind of like the most, there's inexpensive ones. This one's the cheapest. This one's 45 cents per. It's a right angle style, and I do like that it has the true mechanical connects on the side. But for style and looks, and also number of parts in stock, this one, the APEM one, it has 47,000 pieces in stock, which is always kind of promising. I like that. And it gets a lot. And then they do have the 3D rendering of this. So if you're interested in like what does this look like, I like it has a nice sticky outy part. The actuator sticks out quite a bit. It looks like it's easy to solder into place. It is open, so you just have to make sure that it's keep it dust proof, but otherwise looks like a good switch. Not too bad, $1 or so, and then can do up to 300 milliamps at 125 volts. So you could use this as your power switch. You don't need to have any extra circuitry, or you can use it as signal if you like, either one. But a nice switch, SP4T. Good for you when you're making a camera with 4 different filters.
And that's the Great Church.
Where in the world is that part I need? The Great Search with DigiKey.
Just realized these look like when's the next album gonna drop, Ladyada? It's like so anyways, as folks can probably guess, we're probably gonna do a camera. Folks are like, we should start a petition. No, we're gonna do it. We're in research mode. So we'd like to do a camera. I don't think it's going to cost as much as this one.
No, but it'll be a little different. It'll be be programmable and CircuitPython. We'll see. It takes a while to get these designs out the door, but we can start researching and seeing getting ideas. Like I kind of like that little filter switch. It's kind of cool, and I like the fold over paper design. And the battery cases. They did a good job with this. I like it. All right,
Yeah.
cool. That's all I got.
All right. We'll see everybody during the week. Normal
Thanks, everybody.
show, lineup, and more. See ya.
Bye.